Okay, let's talk about the Excel practice. You should be seeing the Excel practice right now. Just double checking. Yes, showing. Great. This is going to help you complete your uh, assignment 3. In here, we're looking at water wells. So it says that we have we've just completed a mission to Sierra Leone. The goal of the mission was to improve the quality of water in 100 wells. So in 100 wells in a certain region, you collect data on the E. coli count from each well before and after your mission. And you need to write a report on the success of the mission. And for that, you need to perform some statistical analysis on the data. You will be looking at the data from different perspectives to determine if the water quality has improved. That's the objective of this assignment. Your major assignment, you're examining a tutoring center. So first thing, we need to put our name. Right, so now our data has filled in over here. And it says first we needed an improvement level. So this is before the wells were dug in millions of E. coli per milliliter. And this is after the wells were dug. The improvement level is before minus after. So equal before, we minus the after, then hit enter. And now we can copy this down. We can go here and double click. So there's the drag, right? You guys have used the drag. There's when you have the black plus, not the black arrows, or the white plus, but the black plus, you just double click and it will automatically fill all the way down. We need to look at some data of some of the statistics. So min, max, mean, median, standard deviation from before, after, and the improvements. So we have before, after, and the improvements. So we're going to use formulas. The formulas are pretty straightforward. They're actually what they say for the most part. Equals min. Oh, look, there's a formula. You can double click on it if you want. You can just click and start. I need to get all of this data. So this starts on B2 and goes to B101. That would be 100. So hit enter. And the before had well with the lowest number would be 0 E. coli. Double check that it's 101. 101. Good. Okay. So, and then we're going to do max. So we want the maximum value in there. Now you could hunt and find it. Like you could spend your time looking for each one of these every time and hope that when the data changes, that's the same cell, but that's not likely to be the case. Equals max. And this is more productive than going through. Here it's just 100. What happens if it's 1,000 wells you got to look at? 2, E, parenthesis, and hit enter. So the maximum number of E. coli was 73. We know that the mean is the same as average, so I'm going to do equal average. In parenthesis B2. And you can click on these. I'm using my laptop, so I don't have the ability to do that as easily. So I'm just going to go ahead and do it with typing it all in. And then that's the average. Remember that the average value doesn't necessarily have to show up as one of the actual numbers. It is the average of all the data. The median. So median is MEDIAN. And there's a formula for it. Again, if you're using a computer with a mouse, it might be easier to click it. Probably not, but you know, it's up to you. And B101. And the data staying the same. That is the middle of all the data points. It puts them in order to calculate this. You don't have to do any of that. Standard deviation, this is the one that it matters what we do. Like the others matter, but this is, we got to be careful because there's lots of them. There's only one minimum, there's only one maximum, one average, and one median. But standard deviation, there's actually multiple standard deviations in Excel. So it's STDEV, and then you'll see there's a bunch of them, right? We want to use the dot S because we're dealing with a sample. So it's dot S, and then we do parentheses. You could click on it again, same as before. B2 to B101. See, and there we have it. We're going to do the same thing here for the after data, except for instead of being in column B, let's see, min, so equals min. This is going to be in column C, so C 2, 1, C 101. Hit enter. So the minimum in our after was still 0. That's good. And then equals max C2 and C. We have a lower max, so that's good. That sounds like things are improving. Again, as I said, they don't always improve. The average of C2 to C101. Ooh, we have a lower average. That's really looking good for us. Median equals. Now, again, this is just because of my name. Your name may have this not work. It's okay. Remember, the objective is not necessarily for it to work. The objective is that we are giving an honest appraisal of the results. Better to be honest with the results than actually give them wrong information so more people start drinking the water from the wells and it's just killing them. That would be horrible, right? So we want to be accurate with our information. You find in life that things have unavoidable consequences when you're not honest. So it's just easier. STDEV dot S, and then C2, C101. I will say that when you do statistics, most organizations that you do statistics with will require that you sign an ethics agreement, unless you're doing stuff in certain fields. They don't really care about your ethics, but yeah. So, and I had to when I worked doing statistics. We're now looking at improvements, so the same information, but now we're going to look at column D. So equals min E2 E1. Again, an improvement of 0 means it didn't change. So that cell, if it was at 20, it stayed at 20. Ideally, the ones that don't change are the ones that were at clean already. That's what we're kind of hoping is the case, but we expect this to happen. Equals max, 2, 1, 30. So the biggest change was 30. So that would be maybe a cell, maybe a well had 20 and or 30 and we improved it to 0. Or maybe it was 50 and we improved it to 20. So it's the same idea. What happens if those are negative? What happens if your numbers or your improvement wasn't good, so they were negative numbers? Well, that means you made it worse, and that's okay. I mean, again, you would want to change that and improve it later if you were actually organizing this this mission trip. So equals bridge and D2 1, close parenthesis. So we improve averagely, as an average, we improved each well 17.07 millions of E. coli less. So that's great. And then median equals median 2, 1, and then so the middle is 19. That's close to the average, so that's pretty good. And let's look at our standard deviation. So equals STDEV dot S, open parenthesis D2, E1. Okay, we're within 7.84 millions of E. coli from our mean. That's one standard deviation. So one standard deviation below that mean and one standard deviation above that mean is 68% of all the wells was in that. Two standard deviations below and two standard deviations above, it's like 95% of our values. So that's awesome. Let's see, what do we need? So we need to do that. We need to build frequency table. And we have a histogram here that can help us to build that. And remember, we have to create a histogram too. Okay. So I'm going to use these to calculate these in my frequency table. First thing, I'm going to set my min. Let's see, what is this supposed to be covering? I should read that. Let's find out. So move this over a little bit. Okay, so calculate the descriptor statistics for your data. We did to decide if it appears there has been improvement in water quality. Thoroughly discuss the use of statistics for the data, including min, max, mean, median, standard deviation. So we can absolutely talk about the improvement. We see an improvement from our max down from 73 down to 53. Our median, so the mean, so the average improvement. Here, the average number of cells was 51, or wells with E. coli was 51 million, and our average after was 34 million. Our middle value, that median, was 59, and it went to 40. And then our standard deviation also came down, which is great. Then remember that standard deviation is a measure of spread. And we can see some of those values show up here. Don't assume that it's going to be just, well, take the max of this one minus the max of that one to get there, because in this case, it doesn't, right? That would only be 20. But in some of the values, they may line up. 59 minus 40 is 19. It does line up, but it won't always. So don't assume it will. And you'll answer that here. So you type in here what you would say, and you would thoroughly discuss min, max, mean, median, and standard deviation. So you would type a paragraph or so that answers this question. Since you collected water from the same source twice, it makes sense to analyze the amount by which each well water quality improved. So again, in here, we're looking at just these two, before and after. Yeah, you're really looking at the before and after. You can talk about this for sure, but you're basically focused on the before and after. On this one, though, it looks like we're talking about how much it's improved. So calculate a data set that would measure the improvement level of each well. Descriptive statistics for that data set, which is up here, the descriptive statistics. Include standard deviation, which we have calculated, so we need to talk about that. Make a frequency distribution and histogram of that data. So this is the improvement data. Okay, that's important, so we know which ones to use. And we can fill out these tables. Okay, all right, so to do this, we're going to need to use this table to fill in our frequency. So we're going to put our equals our min, which we've already got up here, so we don't need to recalculate it. Hit enter. We need our max, and we can just click on it. It might be easier since we don't have a mouse, but that's fine. Bin length we need to round. So we're going to do a formula that says round, and we open it, and we open it again, and then basically this is just our maximum here. So this one minus G34, close parenthesis. There are 11, so we're going to divide by 11, comma, 1. Just rounding to one decimal place. It will make things look nicer. We go up to our low. Our low is going to equal, oh, it's going to equal our low, our minimum. Then we just hit enter. Then our maximum, or our high, so we have a low and then a high. So our low was our minimum. Our high is going to equal our minimum, so this cell, plus the bin length that we got here. And one of the things we want to do here, because we want this to be able to copy down, our bin length isn't going to change. So we're going to put dollar signs there. Dollar sign and dollar sign. And then hit enter. Great. Now we can copy the formula down, and we're going to go ahead and do that all the way to there. So we're not going all the way down, but almost all the way down. And then over here, we want our new low, so the second low, to equal our previous high. So we just do equal, and then we click there. And done. And now this one we can copy all the way to the end, all the way to the very end. There it goes. And you'll see the one that we haven't put in is this one. And this one, we know what the high should be equal to. It should be equal to our max. So we're going to go ahead and make it equal to our maximum. Equal, and then maximum, and then hit enter. Now our words or formula here to describe our bins, just like in your guys' homework, we're going to use the midpoint. So we're going to use a little formula just because it's easier than typing a bunch. We're going to go equal, we're going to open a parenthesis and say, well, if we take our high and we add our low, or take our low and add our high, and then divide by 2. So I'm going to do low plus my high first, close your parenthesis, then divide by 2, and hit enter. And I am going to move it to the center, just because I think that'll look better. And then I'm just going to drag it in. There. And now we're going to do our frequency. And for frequency, you're going to want to use count ifs. There is a frequency function, but unless you are really skilled with Excel, it doesn't work very well unless you're doing lots of data. And by a lot, I mean over a couple thousand. So we're going to use the count ifs. That's what I'm going to be grading on. So that's what I expect you guys to do on your major assignment. So that's going to start with the equal sign, not the plus sign, equal sign, and then count ifs. Count ifs, you can click on it. In this case, double click, so it opens up. And then we're going to put our criteria range. Again, we're doing the improved data, so the D2 to D101, put a comma, and then we're going to use the quotation. We're going to say we want to be greater than, and we're going to close the quotation, and then we're going to use the and symbol or ampersand, and then we're going to put in our F20. So F20, we want to be greater than our low, and then we can close that. And then we want the next criteria range, which is the same. So it's D2, D101, and then comma. And then we want we want the quotation marks. We want to be less than or equal to. We want to close the quotation. Use the and symbol again. ampersand, and this time it would be, we want to be less than or equal to G20 in this case, G20. So our high for that particular row, we close our parenthesis, enter, and you see it only counted one. Now, that's not actually right, and I know it's not right, but we're going to go ahead and copy it down so you guys can see some of the other problems that happen. Okay, if we add this up, I guarantee it doesn't come up to 100. In fact, we're going to go ahead and use the sum function so you can see that. Sum, parenthesis, oh, there we go, got it. Right. Close the parenthesis, 85. Yeah, it's wrong. That should come up to 100. So what's wrong with it? Let's look down here. Wait, this says D12 to D11. I thought we were doing D2 to 101. Well, because we copied it down, we did want this to change, right? We wanted the F20 to change to F30 and the G20 to change to G30, but we didn't want these to change. What we can do is we can go back here, click on the first one. That's where you're going to make the changes, and click in there. And that's what I'm doing because I don't have the mouse. So I'm going to use, and so you just click up there and then just $sign. So this is the absolute value. This is an absolute cell reference. It locks the cell. And then we want to do it again over here so our range doesn't change. We want that to stay the same. So you do it in front of the letter and number of each one. Again, this is why we use in the range and not just listing each one of those. That would be 100 in here to list twice. That would be horrible. And then we're going to hit enter. So we didn't change the other two. We want our lows and our highs to change. So click it now. We want to drag it down again. And we can double click. It'll pull it in. And you'll see that came better, right? So we moved up to 91, but something's still wrong. So let's think about what's happening. So in here, I'm going from this, and I'm counting every number greater than this up to this. And I'm including this here. Here, I'm not including 2.7, but every number greater than 2.7, I'm including up to 5.4, and I'm including 5.4. So I included 2.7, I include 5.4, I include every number below it except 2.7. So I go down to there and I stop. Same way, so this is good. I'm not counting 2.7 twice or 5.4 twice or any of those other numbers twice. I am counting 30, so my max, and I go down to 27, but not including 27, and then I pick 27 up here. The problem is I do have some zeros, and I'm not including them. So whichever way you put your equal sign on one or the other, you can't have it on both, except in one place, either at your first one or at your last one. I'm going to put the first one because I want to include my zero. I want to include my low here. I'm going to add the equals. Equal here. And then I'm going to hit enter. Ooh, and that bumped it up. There were 9 extra ones. So now I have it. I have 100. They want us to include a histogram. So we're not going to answer this right now. We're going to go ahead and include our histogram. And when you do the histogram, I'm going to go ahead and select all of this just to see if this will work. And then I go to insert. To do a histogram, don't use the histogram button. There is one. Just go to recommended charts. And my guess is you're going to get one that comes out that looks like, nope, those don't look pretty at all. Getting there. So see, this is the histogram type looking one, but it's not the right one. Nope, I have too much stuff selected. So we're going to cancel. I'm going to select, I don't actually need my low and high. There's the problem. I just need my bins and my frequency. It'd be nice if I could include the frequency distribution label, but that's okay. Now we select it, we go back to recommended charts. Oh, look at that. That looks so much better. We want to use a bar graph, so we're going to use this one. We're going to hit OK. And we have it in here. We're going to move it because that's horrible to have there. And again, as I shared in the class, it's okay to have a 0 value here on any of these except the first one and the last one. You can't have zeros there. So I have it. Let me click up here. Let me drag it maybe a little bit bigger. And one of the things, I don't have anything labeled, so I need to label stuff. Labeling is important. So what do I want the top? Let's add. So again, there's a couple ways to add. If you're using a Windows, you can go to chart element, and it shows up there. If you're using a Mac, you can go to where is it? Chart design. Yep, there it is. And then you add chart element. We have axis titles. That's what we want to add. We want to add primary horizontal, and we do it again. We want to add primary vertical. Great. The bottom, we're going to put, let's see, that would be millions of E. coli. Okay. Millions. And then over here, we're going to put frequency. Oh no, we could call that number of worlds. And then this is, we're going to call that improvement frequency. That's enough. All right. And then the trick here to making this a histogram, because remember, this is a bar graph. This is not a histogram yet. A histogram is a bar graph with no gaps. So if you double click on one of these, you should pull up this side window that has things like the color, shadow, and effects. But over here where the series options are, you see gap width. And all you got to do is take the gap width and slide it down to 0%. Then you can close this, click off of that, and now we have a histogram that shows the number of wells that were around over 20 that had this positive improvement. We do have a little bit in a few improvements, but most of our stuff was happening over here. So this is one that would have a skewness to it, right? And it would be left skewed, which means more of them were improving. Or more of them still have a lot of E. coli than the amount that actually, even though they all improved, this is an improvement level, they all improved. Some of them improved by more. So a lot of them improved by 20 to looks like about 25, right in that ballpark of improvement of millions of E. coli less. So that's option. That's awesome. You're going to fill that out here. You're going to answer those questions right here. You're going to have this up here. You're going to use this data that you found here, your frequency table. I spelled frequency wrong. Where does the A come from? Frequency, there we go. Okay. So improvement frequency. So you're going to use this table, this little table, and then your chart and answer the questions here. And that's what you're going to do with your major assignment 3. All right. Also, I hope you guys all have a blessed Easter tomorrow and enjoy that time with your family and friends. right. Have a wonderful, wonderful day, and I will see you guys next week.